Till now, we heard very detailed and nice events about multi-cycle project, and now we are going deeply in that detail what we are performing in work package 6 called the automotive applications for multi-cycled solvent-based multi-cycled materials. And for the next page, the outline of the presentation. Initially, we should inform what are we planning and what are we performing in VP6, and then material developments, part manufacturing, and component validation, and in conclusion, we will finalize the presentation. For the next page, I would like to start the introduction of multi-cycle automotive side VP6 base. Generally, till now, you heard the pilot plant demonstration and their activities. Thanks to Martin for his very great presentation. After that, when we take the materials from the LOMI Fraunhofer collaboration, the recyclate-based polymers, the topic comes to our side. That means our general expect on automotive side is the large-scale productions in materials and to manufacture components and then validate it. And also, it's very important to have the comparison of virgin-based polymers and recycle-based polymers and their performances in the component phases. These are the current and also crucial point in VP6 of multi-cycle material resolution. For next page, Ramazan Bey. Yes, that is the currently polymer and fiber-based current structure. I mean, for polyamide and polypropylene based composite structure exists with glass fiber contents. And then for that was the battery carrier part. And for the non-woven side, it is recycled PET and PP-based materials exist here. And that is the general, the material to component general workflow. For the next page, I would like to inform you the current situation. Actually, for the PP-based, PP glass fiber-based material developments, Jana will be inform you more in detail later than me. But for PP and 40% glass fiber content is finalized, and now for the polyamide base in progress. And also that is the generally injection grade materials. And also we have sheet laminate thermoplastic materials performed by bond laminate in our project. And for the PP, it is again finalized for the polyamide in progress. And it's clear that non-woven is completed also. The next page, I would like to give the general workflow material developments thanks to AIM+, SILON, and bond laminate, some completed activities and ongoing activities. And then thanks to, again, the Farplas for part manufacturing. And finally, Stellantis TOFAŞ, we are responsible to give automotive approach that the conclusion and confirmation to solvent-based recycled cresol process materials suitability of the components in automotive side in the end of the project. For next page, I would like to give the speech to Jana. Hi, Jana. Later on, Ramazan Bey will proceed the presentation. Thank you.
Thank you. So if we go to the next page, I would start with AIM+, that is mentioned here as a part of the overall project. Plus helped us to prepare the formulation for the compounded materials. In this slide, we are starting with the other part, one which was the last. I would go back because the last mentioned was the non-woven part, but I will start with that because this is bringing a lot of differences in the technology of the processing of the material. Currently, most of the automotive world for over 20 years is using rPET material that is coming from the PET bottles. This is the picture. You can see the hand filled with the flakes. The producers in, I would say, 80% of the cases within Europe have changed as well their systems of feeding the raw material into the line. These flakes, they are quite lightweight and they are dosed into the extruders or into the lines by pneumatic transport. On the other hand, what comes out of the standard processes, virgin material is in the form of a chips, and as well the standard outcome of the Kreasolv process should be in the form of a chips. It already imposed a bit of an issue for some upscaling because the lines currently are not equipped for 100% of chip processing. So it means you need to change the technology. Finally, we managed to get material that by nature is very similar to these flakes. So we were able to dose it within the mainstream. The bulk density was slightly different from what we are used to. So we had to do some manual dosing, but finally, we managed to get the material in the line and through the line. I can say that it was really industrialized on full-scale industrial line with a throughput of 1,500 kgs per hour. So you can see the difference even described in the values here. If we go to the next slide, you can see what are the typical properties of rPET and virgin PET material. So in the rPET material, we can observe the melting point is slightly lower, and as well the viscosity of the rPET material for automotive purposes is a bit lower. So the process is already adjusted to this. In the next slide, you can see the properties of the material which was used for dosing into the extruder. By the temperature, melting point temperature, it was very alike the virgin material. So the material on its own was very good. I would say first processing cycle, which is not currently the case with rPET flakes. On the other hand, the bulk density was very low. For that reason, we had to use this manual dosing system in order to get it into the line. And otherwise, it was very alike the standard material, which is nowadays used for rPET production. So you can go further. There is only a short description of the process. And in order not to have any harming effect of any dye stuff, first we produced only white fiber where there is no additives used in the process, not to interfere with possible obstacles. But in the end, you can see that compared to PET material coming from bottle flakes, the fiber produced with the Kreasolv material reached very stable and very comparable values. We only had some drop in the elongation, which is even caused, for example, due to some contaminants of residues of the other polymers. But generally, the material was processable and was able to reach the level of the material which is nowadays used and needed for standard soft trims in car interior. Next slide, please. So we can state that in the fiber production, in the rPET material, the outcome of Kreasolv fulfills the requirements on the raw material for rPET fiber, staple fiber or continuous fiber. And the same is valid as well for material for some textile processing. I think this was not validated. Slightly different properties of the material are not fit for use in the automotive, but generally we can say the material could be applicable even in the textile industry. As well, we have processed the polypropylene coming from the Creasolve process. Here I can say it was fully comparable by nature of the chips, by properties that were reachable with the standard virgin polypropylene grades used for compounding. And there were no issues at all in the quality of the material, in the processing, and as well in the assessment of the final product. And because the chips are identical to standard raw material, there were completely no issues on any part of the production process. We can go further. This is a part of bond laminate. In the previous part of the presentation, we have seen that there are carpets or soft frames made using the rPET and PP material. And as well, there are the laminated materials. So the material which was used for compounding was as well processed in the bond laminates, where it was mixed with glass fibers. These fibers, as far as I remember, they were not recycled because of it had to be a long length. So as well here, the content of the recycled material, of the recycled polypropylene, didn't cause any harm to the processing and as well to the final properties of the material. I can only say generally the compounding process in SILON and as well here in bond laminates can work with 100% of the recycled polypropylene coming from the Creasolve process. In the compounding, it was blended with polypropylene in order to reach the required properties of the material for further processing steps. And as well here, the content could have been adjusted accordingly. But generally, polypropylene can be replaced by recycled polypropylene up to 100% of the overall content of the polymer. So as well, here we can state that the recyclate rates can reach by far higher levels. And if I go back to our experience, currently the recycled material for compounding, especially the polypropylene recycled material, is normally dosable at the level of maximum 20%. Otherwise, it's interfering with the required properties of the final material. Can go further. Can be, yeah, thank you. This is the outcome of the recycled polypropylene, which is called TEPEX. So it's laminated soft sheet, which is used then for various parts in the vehicle, interior parts mainly. And as well, the haptics has not been anyhow affected by the use of any of the recycled materials, either polypropylene or polyamide. Can you go further? Thank you. And this is again for Tuba and for the work of the further partners.
Yes. Till now you hear the material developments in multi-cycle-based materials, polyamide, PP, and PET. And now think about that in general overview. We produce the materials and scale them up. And now it's time for processing the components. And please, Ramazan Bey.
Okay, thank you, Tuba. Hi there, everybody, and good day. This is Ramazan from Farplas. and I would like to today I will talk about what we have done so far in the MultiCycle project as a demonstrator partner. First, I will start with a quick company overview. We, as a Farplas, are a tier 1 company located in Turkey, and we are manufacturing interior, exterior, and under the hood automotive parts for the OEMs located in Turkey. And Farplas, as you see in the slide, is a full system supplier, starting from the design and all the way through tooling, processing, painting, testing, and analyzing. We are providing extensive solutions to our customers thanks to our production capabilities. Apart from conventional injection molding, we have equipped with specific manufacturing and assembly lines, including cure on demand, in-mold decoration, wrapping, and as well as the fiber form line, which we used to manufacture the use case parts in this project. Here in MultiCycle project, we involved as a demonstrator partner that I mentioned before, and we provide two automotive use cases which are quite challenging from the point of processing. Our main objective is in the project is to remanufacture the provided use cases by using the materials comes from creosol process. Of course, we didn't use the materials directly. Our respective partners did the compounding and composite preparation studies according to our needs for processing in injection molding line. At the beginning, we supplied scrap thermoplastic parts with the different versions of one of our use cases, mostly comprised of glass and carbon fiber and PP and polyamide-based thermoplastics, and also the organosheets Jana mentioned before. After receiving the materials, we have started to manufacture our use cases, and we proceed at a certain point. Okay, our use case parts are battery carrier and door panel pocket. I won't give that much detail about the parts specifications and necessities. Tuba will cover this later. Both parts includes inserts to be thermoformed, and the both parts can be manufactured by using a fiber form line, which combines thermoforming and injection molding in one process. When it comes to processing the battery carrier parts, it's quite challenging due to its complex geometry and the stiff L-shaped included in these parts. We need to be more careful. We need to be more careful about processing these parts to prevent any burn marks or any excessive shrinkage. And for the door panel pockets, actually the material is easy to process, but the problem is here, the main problem is the part contains flat, big sheet to thermoform in the fiber form line, which is quite challenging due to the this line is propelled with the robotic system, and it could be a problem to carry on these inserts to the mold and hang it for thermoforming. Here is our fiber form lines working procedure. The line is propelled by fully integrated robotic system. It's in a full automation. And the first, the robotic arm holds the insert and put the ER oven to heat. And the second, the ER oven heats our inserts at a certain temperature to soften and ready for forming. And after that, the robotic arms take the insert from the ER oven and hangs the insert into the mold cavity. And after placing the insert, the mold is closed and the forms the insert with an exact shape which parts needed. Finally, the overmolding is occurred over the thermoformed insert, and after cooling, the part is ejected and conveyed to the conveyor belt with the automated robotic system. So let's watch the video and see how our fiber form lines work and how we manufactured the battery carrier parts with this manufacturing line. First, the robot is positioned the insert on the table. And here is the infrared oven to heat up the insert at certain temperature. And robot takes the previously manufactured parts from the mold. And insert is ready to thermoform. It's already softened by the heat. And robot starts all the way around from the beginning. Let me skip a little bit. And our part is ready to ejection. An approximate cycle time has occurred for these parts around 80-90 seconds. And as our partners mentioned before, we used the PP pellets with glass fiber reinforced, which comes from cryosol process, and also the inserts, which is organic sheets like Tepex, and they are included the MultiCycle material as well. Okay, so we manufactured the battery carrier, both original and recycle-based material, and we tuned the processing parameters, made the production steady state to implement the serial production conditions. Process windows are almost identical for both cases. We just tuned the holding pressure and holding time for the recycle-based material. And after visual inspection, we didn't see, as I mentioned before, we didn't see any burn marks or other injection molding defects or any other excessive shrinkage on the parts. And the next thing we did for this, actually, after manufacturing, we conducted CMM measurements for the battery carrier parts. And the battery carrier parts consists circles, rectangles, and polygon points. And the measurements was based on these functionalities. We detect the position of these specific functionalities to see if the part is okay for the next steps. And after measurements, as you see on the table, all the points pass the test, and we send to parts to TOFAŞ site for further validation. And here is the example of the circle shape on the battery carrier. We have lots of them, and also the polygon shape, as you see here. And you can see the part test is already done and completed successfully. And for the door panel pockets, pre-consolidation of the non-wovens are already completed, and preliminary processing trials have been done, but we needed to upgrade the material for our needs. Natural fiber reinforced laminates, but right now it's a non-woven and it's a fluffy structure. And actually we are still working on the processing of the door panel pocket. Hopefully we will finalize and produce the parts successfully within a couple of days. Okay, that's all from my side. Thank you for listening.
Thanks, Ramazan, for your great presentation. And now parts are produced and come to TOFAŞ for the start validation activities. Now for the next page, Ramazan, we can start. Yes, I divide into two sections. Initially, it's very important to have material characterization in compounded version, because the starting point in the automotive section is define material properties, physically, thermally, and mechanical level of the material. Then starts the validation testing, qualification test, activities. Next page. I would like to mention you compounded version of recycled based polypropylene GF40 that is scaled up by SILON. Also, initial formulation contents performed by AIM+. And we also can say in generally, in physically form of the material, it is positive. And also in mechanical conditions, tensile values are over and very, very similar. And the flexural modulus and strength is quietly similar. It is some little differences, Also, in addition with isot impact, that means that it's important in some structural parts, the test value, and better than version 1. And finally, in thermal conditions, it has little difference, but it is not an inconvenient situation. It has to be validated on the component. Also, design support, the related component design support is very challenging. So for now, the starting point is the positive in virgin-based polypropylene comparisons. And then next page. I would like to start the definition of the components battery carrier, what it is and why we are using it. Especially the general work of this component is the carry the battery for internal combustion engine vehicles, and the storage space in the the very limited position in the motor section for the underhood, and keeping the batteries secured in a place. It's covered in a belt with a belt, and keep the battery because our vehicles are dynamic and running on the roads, so it must be very robust during the your car is running and during the stopping conditions in the end. And as Ramazan said, the the production methodology is hybrid composite injection molding process. And this injection molding process is a well-established production process based on the high pressure injection of the raw materials into the mold that shapes the polymers to the components that is the desired form of the design. And the melted plastics controls, cools, and hardens, and then we are receiving the parts from the mold. And that process is reliable methodology in solid plastic with high quality conditions. So after we produce that, we go to the vehicle position and test apparatus position of the component. For the next page, these are the generally validation tests that we performed for recycle-based, creosote-based polypropylene, 40 glass fiber material. Environmental requirements are very, very important for us because the components live such a kind of environmental conditions. And this trace system will be exposed to underhood of the vehicle, and it can be subjected to elevated temperatures and below freezing temperatures and the vibrations. So what can we do that? The extended heat aging test, temperature cycling, thermal shock test are very crucial in the end though to validate the environmental condition exposure test in static condition. Then the battery has some specific battery acids. They are very aggressive acids, so its resistance is very, very crucial during the usage of the component, the durability on the car. Then resistance to chemicals, for sure, each component must be resistance related to interior, exterior. In any case, where is used in our vehicles. And the dimension requirements and appearance requirements, as Ramazan said, it's positive resulted. And also molding check can be added in that condition. Of course, battery installation in different environmental is completed and no any issue if we compare that. And finally, vibrational and plus and minus thermal fatigue on vehicle. That is a dynamic, very hard validation. It reflects the so much years on the car, and we do not see any difference in between the virgin-based polymer or polypropylene and the recycle-based polypropylene condition. For the next page, Ramazan, if you open, for the battery carrier conclusion, I can today say tests
2 minutes to go, please.
Sure. Tests are performed simultaneously and together on vehicle position, and no significant difference between that material, virgin and creosote-based recycled. Then next page, I will only say a couple of words about the non-woven side. Thanks to SILON to produce staple fiber production, then go to non-woven Gen 2 fiber. Then pre-consolidation is needed for pressing, and now at the moment Farplas is working on the processing of the door panel packet in the end. The next page. Also, you can have a look at the non-woven performances, that is recycled-based PET and PP based materials for interior applications. It is positive if we compare about the Stellantis material specs, and it's very important also. I have to figure out that odor is very, very important and challenging issue in recycle-based materials, also in interior of the car. For the rot resistance, we can also add that we do not have any unpleasant odor in the material itself. That is really crucial for the automotive point of view. And the next page, we are proceeding. Thank you.